Well, when I think of I think of things that happen together, right? Cooperate, working together, co-ed, living together or going to school together, like co-ed dorms my daughter in, and I worry, oh my God, she's in a co-ed dorm with all those boys. So I think about together, right? And I think about together as being a process where things happen at the same time, and therefore I think of evolution of two species that's coordinated or cooperative in a sense, or at least happening together. And the formal definition that you could think of when you think of coevolution is this one: reciprocal evolution of two or more species. Now, to keep it simple, we can just think of those two species we talked about in the first photo, the bird and the plant, and we could think about each one of those species, the population of birds and the population of plants. Each of those species are evolving, but they're not just evolving on their own, they're evolving back and forth. That's what reciprocal means, back and forth in response to one another. So as the birds' population evolves, that changes the environment, right? The biotic environment of the plants' species. And that population then can evolve in response to the birds. And then as the plant evolves, that changes, in a sense, the resource, right, of the birds. And that can cause further evolution of the bird population. And so this reciprocal or back and forth evolution is that process we call coevolution. Each species imposes a selective pressure on the other species by being part of its biotic environment. And what it requires is that those two species have a very strong ecological interaction to generate that selective pressure. So let's think about some ecological interactions and the potential for coevolution. Here's 4 photos that bring to mind unique ecological interactions. The top left one is mutualism. And if you can't make it out, this right here is a blind shrimp. It's a very pale colored shrimp that lives in a burrow. And this is a very, very sightful goby. So it can see perfectly well. And this goby will live in close association with this shrimp. The shrimp maintains a very clean burrow that the goby can hide in with the shrimp. The goby alerts the shrimp to predators by a little flick of its tail, and that vibrational signal causes both the shrimp and the goby to know that a predator is about, and they right back into that burrow. So at least that part of their interaction causes us to call this a mutualism, where both species benefit from that interaction. Alternatively, we've already talked about plenty of interactions we would label as competition. And in this case, both this coral that you can see here growing in these tall white columns and this encrusting sponge, which is growing over top of the coral, they're competing for space. And if this sponge manages to outgrow and completely cover over the coral, it will have won that competition. So both of these species are negatively affected by the interaction. In the bottom left, we see a classic predation, a predator-prey relationship, where this snake here, being the predator that eats this newt, has a positive benefit from the interaction, and the newt has a negative impact because it gets eaten, right? So it dies. So the snake gets energy, the newt potentially dies, and that means we have a plus-minus. Now on the right here, bottom right, we have one final interaction called a commensalism. And a commensalism is one where one species benefits from the ecological interaction, whereas the other species doesn't seem to benefit or lose very much. And so this is a mussel. You can see this bivalve mussel. And on the shell of the mussel are many little round white things called barnacles. These barnacles are using the mussel as a space to grow. And potentially the mussel's camouflaged by it, but most things in the ocean smell more than they see, and so it's not really gaining much of a benefit. If anything, it just doesn't notice that the barnacle is growing on it because the surface of its shell isn't affected in any negative way. Now I want you to think about these 4 ecological interactions and answer the following true-false question. And this question has to do with the potential for coevolution to occur during these ecological interactions. True or false, a pair of species engaged in commensalism can co-evolve. A pair species engaged in commensalism can co-evolve.